man becomes, as it were, the sex organs of the machine world, as the bee is to the plant world, enabling it to fecundate and evolve ever new forms. The machine world reciprocates man's love by expediting his wishes and desires, namely, in providing him with wealth. In this video, we're going to examine this statement as it applies to both the blockchain and artificial intelligence. 2009 saw the first Bitcoin mined. The Genesis block was mined by Bitcoin's named yet unidentified founder, Satoshi Nakamoto. As you may already know, Bitcoin is created during a mining process in which Bitcoins are mined by computing algorithms. This is called the proof of work mining process, and it is how Bitcoin and most other cryptocurrencies are mined today.
They listen for transaction messages that are validly signed on the network, and they bundle them into what we call a block. They announce this block and they say, now you all take this and add this to your copy of the ledger. We call that ledger a blockchain because the miner has just announced a block, and that block is mathematically linked to all the blocks in the past. They're chained together like a big long string. They're given a reward by the network for performing this public good. And that reward comes in two different ways. One, a Bitcoin miner is allowed to stick in the ledger of transactions for that 10 minutes one special transaction. And as it says, I, the miner, pay myself 12.5 Bitcoins. And they came from nowhere. This is the only time on the Bitcoin network that anyone is allowed to ever have a transaction that didn't have any inputs, that literally created money out of thin air.
For a Bitcoin miner to increase the amount of Bitcoin that he or she can mine, they are required to increase the amount of processing power they contribute to the Bitcoin blockchain. By doing so, they increase the amount of transactions they are able to process on the Bitcoin blockchain and are rewarded with more Bitcoin. The first Bitcoins were mined on CPUs, but it soon became clear that GPU mining is far faster and efficient. Before Bitcoin, graphics processing units, known as GPUs, were used primarily for video gaming. The processing power of these units grew as the requirements of the gaming industry grew. Around 2011, GPU processing speeds began to accelerate exponentially. This was due to the processing requirements needed to mine Bitcoin. The demand created by Bitcoin miners encouraged video card manufacturers like Nvidia to create increasingly more powerful GPUs at a rate that was higher than the requirements of the gaming industry alone. Hardware requirements in gaming are limited partially by the software game developers use to create their games, and by the investment gamers are willing to make into the gaming hardware needed to run games they want to play. Bitcoin mining is not limited by these restrictions. When you buy a GPU for gaming, you get entertainment in return. On the other hand, when you buy a GPU to mine Bitcoin, you are rewarded with coins that can be exchanged for money, thereby paying for the GPU and encouraging you to buy more GPUs to mine more Bitcoins. To better understand how this expansion in computing power has benefited humans and also machines, we'll now take a look at the rise of modern AI. The origins of AI are as long and complex as the origins of human beings. In fact, the two are interwoven. Modern artificial intelligence has emerged largely due to recent advancements in machine learning and neural networks. These neural networks allow machines to learn and execute tasks previously thought impossible.
Say you want a bot that can recognize what is in a picture. Is it a bee or is it a 3? It's easy for humans, even little humans, but it's impossible to just tell a bot in bot language how to do it, because really we just know that's a bee and that's a 3. We can say in words what makes them different, but bots don't understand words, and it's the wiring in our brains that makes it happen anyway. While an individual neuron may be understood and clusters of neurons' general purpose vaguely grasped, the whole is beyond. bad. Nonetheless, it works. So to get a bot that can do this sorting, you don't build it yourself. You build a bot that builds bots and a bot that teaches bots. These bots' brains are simpler, something a smart human programmer can make. The builder bot builds bots, though it's not very good at it. At first, it connects the wires and modules in the bot brains almost at random. This leads to some very special student bots sent to TeacherBot to teach. Of course, TeacherBot can't tell a B from a 3 either. If the human could build TeacherBot to do that, well then, problem solved. Instead, the human gives TeacherBot a bunch of B photos and 3 photos and an answer key to which is what. TeacherBot can't teach, but TeacherBot can test. The adorkable student bots stick out their tongues, try very hard, but they are bad at what they do. Very, very bad. And it's not their fault really. They were built that way. Grades in hand, the student bots take a march of shame back to BuilderBot. Those that did best are put to one side, the others recycled. BuilderBot still isn't good at building bots, but now it takes those left and makes copies with changes and new combinations. Back to school they go. TeacherBot teaches, tests again, and BuilderBot builds again. And again, and again. Now, a builder that builds at random and a teacher that doesn't teach, just tests, and students who can't learn, they just are what they are, in theory shouldn't work, but in practice it does. Partly because in every iteration, BuilderBot's slaughterhouse keeps the best and discards the rest, and partly because TeacherBot isn't overseeing an old-timey one-room schoolhouse with a dozen students, but an infinite warehouse with thousands of students. The test isn't 10 questions, but a million questions. And how many times does the test, build, test, loop, repeat? As many as necessary. At first, students that survive are just lucky, but by combining enough lucky bots and keeping only what works, and randomly messing around with new copies of that, eventually a student bot emerges that isn't lucky, that can perhaps barely tell B's from 3s. As this bot is copied and changed, slowly the average test score rises, and thus the grade needed to survive the next round gets higher and higher. Keep this up, and eventually from the infinite warehouse slaughterhouse, a student bot will emerge who can tell a B from a 3 in a photo it's never seen before pretty well. But how the student bot does this, neither the teacher bot, nor the builder bot, nor the human overseer can understand, nor the student bot itself. After keeping so many useful random changes, the wiring in its head is incredibly complicated, and while an individual line of code may be understood and clusters of code's general purpose vaguely grasped, the whole is beyond. Nonetheless, it works.
Efficient neural networks require a large amount of computing power that currently only GPUs can provide. As we examined earlier, GPU technology has advanced rapidly over recent years, and Bitcoin has had a big role in incentivizing these GPU advancements. AI is now a part of our everyday life. In fact, video platforms and search engines are using AI to connect users with content. So it is highly likely that AI has led you to this video. It can be argued that modern AI cannot be available today without the advancements in GPU technology associated with the rise of cryptocurrency mining. It is easy to believe that we are developing these blockchain networks, and it is simply a coincidence or a matter of convenience that AI is emerging at the same time. I don't believe that this is a coincidence, and here's why.
When you say the medium is the message, does that leave any room at all for criticism of individual, say, television programs?
Or content.
Yes.
You see, it doesn't much matter what you say on the telephone. The telephone as a service is a huge environment, and that is the medium. And the environment affects everybody. What you say on the telephone affects very few. And the same with radio or any other medium. What you print is nothing compared to the effect of the printed word. The printed word sets up a paradigm, a structure of awareness which affects everybody in very, very drastic ways, and it doesn't very much matter what you print as long as you go on with that form of activity. I said that the effect of TV, the message of TV, is quite independent of the program. That is, there is a huge technology involved in TV which surrounds you physically. And the effect of that huge service environment on you personally is vast. The effect of the program is incidental.
If we view blockchain technology as a medium, then what is the message? Perhaps the message is that humans and machines are as interdependent as bees are with flowers, as Marshall McLuhan suggested. If humans are the sex organs of machines, then perhaps blockchain technology is the DNA from which artificial intelligence will emerge. Thank you for watching. Please share your thoughts on this fascinating subject in the comments below. You can support the creation of more videos like this by using the wallet addresses here or in the description below.